Okay, need to continue this video, and I actually kind of want to start explaining this problem a little bit different from the beginning. And that is because I didn't notice that we have all these nice tips and tricks right here within the problem to help us get the right answer. And so, I mean, to get a better answer. And so I'm going to start by taking this problem right here, and I'm going to just like factor out the negative, because see how there's a negative right here, a negative right there. So I know for sure it has to be one of those, actually. And because I know it has to be one of those, because there was this negative right here, now I can narrow down my answers to see which one matches the graph. So I'm going to open up the graph, and okay, so here's the graph, and I'm going to do the negative out front, and then one of them was x minus 5 and then plus 9, and the other one was minus 9 and plus 5. We just want to see which one's going to match the original graph, right? Because it has to be equivalent to, that means the graph would match, right? So minus 5 plus 9. So I'm going to try that one first. X minus 5 and x plus 9 and equals 9. That looks like it's the same. I'm going to check on the other one. So negative x minus 9 and x plus 5 equals 9. Not the same, right? So it has to be the one that's this x minus 5 right there with the x minus 5 in it. That was lots easier than it needed to, and then than I had. I didn't have to do anything to that problem. I just saw that there was the negative, so that's why it had to be either this one or that one. I graphed both of them, and I got B was matched the graph. So I'm going to, for the notes, equivalent expression. So we're going to write equivalent expression, because that's what we were doing. Equivalent expression. We had negative x squared minus 4x plus 55 equaled 19. And then the options were negative x minus 5, x plus 9 equaled 9. And then, and so this is what I looked at, is must have a negative. Must keep the negative. And so then minus 9, x plus 5 equaled 9. Those were our options. But then must keep the negative, and then the other thing that we needed to remember is the graphs match. Graphs should match. Cool. Oh, wrong thing. So, coming back to the assignment. Here we go. Okay. Which is this expression in factored form? So this is how I would do this one. I can see that there's an x in both of these. So for sure, I want an x in front, so it cannot be C. I can see that both of these are negatives. So I for sure want a negative in front. So it can't be B because it's got a positive in front. I meant to leave it the same color. Okay, and then if I factored out a negative 3, it would leave me with only positives. So it has to be this. Another way of doing it, if I knew that I had to have a negative 3 out there, actually we could like reverse engineer it. If I multiplied this in there, so negative 3x times 4x would be negative 12x squared, and negative 3x times by 3 would be negative 9x. We could, once you see that it's going to be, they're both negatives, we could try to like reverse multiply it, but that works fine. Okay, next part. expression in factored form. So how we did it in class and how still works is we can graph it. And then notice, yeah, so let's graph it. So we're going to do 2x squared minus x minus 15 in decimals. I'm going to delete all. And that was 2x squared, right? 2x squared minus x minus 15. Maybe. I zoomed in too much. Okay. 2x squared minus x minus 15. So if I graph that, I can see my two zeros. I don't think it zooms in nicer, does it? Does it zoom in nicer if I go over here? No, it's still pretty, okay, negative 2.5 and positive 3.0. So I can see that from, 3, From negative 3, I can see, I know that that opposite thing has to be in place. So since this is a positive 3, I know I'm going to have an x minus 3. And then since this is a negative 2.5, my other part has to be plus. Does that make sense? So I'm going to have x minus 3, and then the other one is going to have a plus. I'm going to come back in here and just look at the answers to find one that looks similar. Okay, so I know I have to have an x minus 3, right? There's literally only one of them. That was pretty easy. And there we go. And then the other one did have a plus. So we graphed it. We got the points negative 2.5, 0, and we got the point 3, 0. So the 3, 0 meant it had to be x minus 3. And the 2.5, all I needed to know from that is that would have to be like an x with a plus in it. And then this is the only one that matches. And I'm not going to do the notes as much right now. I'm sorry. I want to finish this. So, okay, 7i multiplied by 7i. We didn't directly do this one, but it's not too hard. 7 times 7 is 49, right? And then I times I is I squared. But then if you remember, I squared is the same thing as the square root of negative 1 is I times I times I. And the square I is the square root of negative 1. So the square root of negative 1 times the square root of negative 1 is negative 1. So the square root of 49i squared would be 49 times negative 1, which would just be negative 49. So it'd have to be A. And then, let's see, I haven't done this color. Okay, this one, we haven't done these in a long time. So I'm going to go like this. I'm going to split this problem into 2 pieces. So I'd have 1 over negative 5i. I'm going to just split this top part. I'm going to split it. And negative I over negative 5i. And if I split it like that, then I can see if I have a negative and a negative, that becomes a positive. And if I have an I and an I, they're going to like divide, cancel. They're going to become 1. So that would just be a 1 left over. So these 2 negatives make a positive. And that would be, so it would be positive 1/5 because there's no i's left on that. And then there's still the minus that's here. So it's going to be minus 1 over 5. And then the I can go right here. But we don't want the I on the bottom. We want the I on the top. So we can times this by 1 in the form of I over I, because we don't want the I on the bottom. You can see the I's are all second here, right? So this is really just like multiplying it by 1 in the form of I over I. And what that does is it creates these 2 i's on the bottom that become a negative 1 like we learned up here on this problem, right? I squared becomes negative 1. So that means that this is going to be 1/5 still, but this negative multiplied by the negative right here, like these two, can you see what I'm talking about? Let's see, yellow. This one and that one makes it become a plus. And then it's just 5 on the bottom, and now what's on the top is just a 1, and then there's an I next to it like that, because that's what would happen. So this is my final answer on C. We didn't do that one. Don't stress if it's the one that you miss, right? It's okay. And then we did not do this one a lot. We did do it, and I don't think it's too bad. It's completing the square. So this is how we do it. Remember that this is the A in front of the X. This is the B in front, X squared. B is in front of the X. And so we want to find the C that makes that a square. So we want this to be something squared. And how we did that is we took that number and divided it by 2. So 18 divided by 2 would be 9, right? And all we have to do for our answer is just put what 9 squared is. So 9 squared is 81, and that's our answer. So we've done that before. We didn't call it completing the square, but we did do it. Or maybe we did. Okay. The number of real solutions. So this is one that you can also do in Desmos. We can graph it. So 11, 8, and 1. So we can graph it, especially if I can figure out what happened with this. Oh dear. Okay. So it was 11, 11, and then I hope this is a plus, and then 1. Oops. And then I think I need to, is it all plus, plus, plus? Yep, it is. Okay, so if I graph that, I can see that there are 2 solutions, and they cross the x-axis, so there are 2 real solutions. So just 2 solutions because they cross the x-axis. So the answer is A. And then substitution, it says use substitution. We're going to do again, because it's our friend and we can, we're going to do Desmos graph. So we have negative, negative, negative. Oof. Okay, so that's just going to be, I'm going to clear this out. Delete all. So negative x squared minus x minus 1. Is one of them, and the other one is negative x minus 2, negative x minus 2, and they cross at those 2 points, so negative 1, 1, negative 1, negative 1, and 1, negative 3. We just need those points. So negative 1, negative 1, negative 1, negative 1, and 1, negative 3. Cool. That was D, and that is the end. Voila! Okay, so we probably need to put some more notes in here, right? So let's add some notes. Where did we leave off? We left off on, how much room do we have? Oh, not much more room to do that. So we had an equivalent expression. So let me see, what else did we have on here? We needed to do factored. I'm going to put that it's undo the multiplying. So I'm going to do negative 12x squared minus 9x. Is that what it was on that one? So that was up here, because I think that was the last one. Yeah, we did equivalent expressions. So then I'm going to do, oh wait, I'm back in here. I'm going to do, we just needed negative 12x minus 9x. Both have x and negative. So it'd be negative 3x, 4x plus 3. What else did we have? We had factored form. The next thing we had is we graph it to help us with the factored form. So graphs to get factored form. So if we did, we got the points negative 2.50 and 30. This went into x minus 3. And then this one, I didn't know for sure what it was going to be, but I knew it was going to be a plus, right? Because those are opposites. And there's only one. Like that. So that was easy to get that one. Then we had, the i's. So I'll need to write the I. This one, probably 23 is the hardest one. But again, if it's just one, don't stress. So then we needed that I squared equals negative 1. So if I had 7I times 7I, that equaled 49I squared, which this part was negative 1, so it's negative 49. Okay, then the next one, we did a couple fancy things on that. We had we split that. So we had 1 minus I over negative 5I. 1 minus I over negative 5I. So what we did is we split this. So it was 1 over negative 5I and minus negative I over negative 5I. And then we saw, that was negative. Sorry, that was not supposed to be there. That one right there. Okay. Yep. And then these i's canceled. And then those two combined to be a plus. So then it just became 1. And then it went over here. So I did 1 over 5. And then minus 1 over 5I. But we didn't like the I, so we multiplied it by I over I, making this negative 1 again, which means we made this negative and that negative become a plus. And then, so that's no longer, like that becomes a negative 1, makes that thing become a plus, and then the I is stuck. So it's going to be 1 over 5 plus 1 over 5I. And then can I squeeze more in if I write it small? Should I put the numbers that these go with? I'll go back and put that on if you need that. Okay, we got that one. We completed the square. So we took our, so what we did here is we did b divided by 2 and we squared it, and that's the number that we had right here. So this was the b right here. So if we just take that b, divide it by 2, and then square it, that's all we need for that one. So completing the square. And what number is that one on? That was on 24. So this is 23. This is 22. This is 21. This is 20. So on 24, complete the square. if we have ax squared plus bx plus c, we're going to do b divided by 2 and square it is the number to complete the square. So we did 18 divided by 2 squared was the same thing as 9 squared, which was 81. I should put always positive. Going to be a plus. Always positive. What else can I fit in here? I'm trying to fit it all on 2 pages because that's what makes sense to my brain, and I'm sorry that it's squished in there, and if you don't like it, then you don't have to do your paper like that. The number of real solutions was based on just graphing it, and if it crosses the x-axis, that's it, right? So that's going to be, where are we going to put that one? 25. Sorry that it's so squished in there. I'm going to get red. Nope. What color will I get to fit right there? Pink. So 25 number of real equals the number of times it crosses the x-axis. And now I'm going to put graph it. One more I have to squeeze in there. We can do it. Okay, then we said, oh yeah, Desmos graph, see where they cross. 26, Desmos graph, see where they cross. Okay, 24, 25. Can I squeeze 26 right here? 26, Desmos graph, see where they cross. Whew. Okay. All right. That's the end of this video. Hopefully this helped you, and you can watch it again and again.